Good morning, sixth graders. Happy Tuesday to you. Okay, so we only have 2 lessons left, and to be honest with you, I think I might hold off on fossil fuels, and our geology unit the test and the little mini project that we're going to be doing will probably stop with lesson 6. The mini project that we're doing is based on this particular lesson, so I would pay very close attention. And as always, you can pause the tape at any time, and if you don't like the sound of my voice, you can always log on to the Savvis site, and the other girl will read it to you. Okay, so the rock cycle. What is the rock cycle? Rolling along. The Himalayan mountains are eroding at a rate of about 2.5 millimeters per year. So when you think about 2.5 millimeters, that is about, let's get on the millimeter side, 1, 2, about in between my 2 fingers there. That's about 1/10 as fast as your fingernails grow. But the Himalayas were formed millions of years ago, so imagine the total mass of rock that has fallen down the mountain and that has been swept out to sea over millions of years. The piled weight of eroded particles will squeeze the bits together on the seafloor, and new rock will form. Then ancient bits of the Himalayas will be recycled inside the new rock. So what is the rock cycle? Natural forces act on the Himalayas. In fact, rock in the Earth's crust is always changing. And here comes that blue, the key idea. Forces that are deep inside the Earth and at the Earth's surface produce a slow cycle that builds, destroys, and then changes the rocks in the crust. The rock cycle is the series of processes that occur on Earth's surface and in the crust and the mantle that slowly change rocks from one kind to another. For example, weathering can break down granite into sediment that will later form sandstone. One pathway through the rock cycle. So there are many different pathways in which rocks can move through the rock cycle. For example, Stone Mountain near Atlanta, Georgia is made of granite. The granite in Stone Mountain, shown in Figure 1, formed millions of years ago beneath the Earth's surface as magma cooled. Beneath the Earth's surface. So what kind of igneous rock is granite? Intrusive. After the granite had formed, the forces of mountain building slowly pushed the granite upward. Then, over millions of years, weathering and erosion began to wear away the granite. Today, particles of granite consistently break off the mountain and become sand. Streams carry sand to the ocean, and what might happen next? Let's think about that. So we got sand, perhaps sandstone would form. So let's see what weathering and erosion, that act starts to wear away the granite. So over millions of years, layers of sand might pile up on the ocean floor. Slowly the sand would be, compacted, or perhaps calcite is dissolved in the water, would cement the particles together. And then over time, the quartz that once formed the granite of Stone Mountain would then become sandstone, which is a sedimentary rock. Sediment could keep piling up on the sandstone. Eventually, pressure would compact those particles until no spaces were left between them. The silica, which is the main ingredient in quartz, would then replace the calcite cement. The rock's texture would change from gritty to somewhat smooth, and after millions of years, the sandstone would have changed into the metamorphic rock quartzite. So if you think about, we have granite becoming sandstone and then sandstone becoming quartzite. If you look at the section on the metamorphic rock that we covered, those rocks are mentioned in there as well. Now, this is a really great page of the rock cycle. This looks very similar to the notes that you will be given on lesson 3 point, I believe this is 7. There it goes. I'm looking for something over here on the side. Let's see what we're doing here. Okay. How do rocks form? Let's be a rock star. Through melting, weathering, and erosion, and heat and pressure, the rock cycle constantly changes from one type into another type. It wants you to interpret the diagrams. Now, I'm going to talk about this, but this page is actually what I'm going to assign you to after I finish reading. You know how after I've read, hopefully you're going to go back and you're going to answer these questions here and these questions here. We're only going to page 121, as I told you before. And here's these little line blanks here. They want you to write things in there. So they want you to write, let's just, so you know what you're supposed to do. I'm not going to be a brainiac. I'm going to go up here, and I'm just going to read the directions. Study the diagram, then fill in each blank arrow with the correct term. I don't even have to think about them. They're giving them to me. Melting, weathering and erosion, or heat and pressure. Just for the sake of the size here, you can feel free to abbreviate weathering and erosion as W and E. Now, once again, we have processes going on here. So here's that deposition. Layers are being laid down. And see how this is filled in with heat and pressure, then bends those rocks. Then it will melt when it's near a pocket of magma or lava flows on top of it. And then, so that's volcanic activity, will then cool and the rock will become igneous. And then over millions of years, rain and wind will begin to weather and erode it into sediment, and the process starts again. But that's like the rock cycle, so you can see the circle. But it doesn't necessarily have to go in that order. Once you're a sedimentary rock, you can become igneous. So just look at what process do you think that you would become igneous? Or if the igneous rock, instead of being worn away, it might get baked, and then what process would turn it into a metamorphic rock? So we're going to read this last section here. And remember, we're going to end up doing the review sheet. And then our mini project comes from this particular chapter, lesson. The rock cycle and plate tectonics. You heard me mention that the Earth's crust is like, if you can imagine, a bunch of graham crackers on a layer of chocolate pudding. And maybe it's like this much chocolate pudding, like this, and the graham crackers on top, and you were running around, those graham crackers would move a little bit, they would bump into each other, they would crumble, one might push another one up, and that's sort of what's going on with the Earth's crust. The changes of the rock cycle are closely related to plate tectonics. Recall that Earth's lithosphere, which is the ground, the hydrosphere is the water, is made up of huge plates. These plates move slowly over the Earth's surface as a result of convection currents in Earth's mantle. As the plates move, they carry the continents and the ocean floors with them. Plate movements help drive the rock cycle by helping to form magma, the source of igneous rocks. Doesn't that seem important? What helps drive the rock cycle? If the section is on the rock cycle, you think you would want to know what exactly is making it happen. And it forms that magma. In this case, you can imagine the magma as being like very warm chocolate pudding. Where ocean plates move apart, magma formed from melted mantle rock moves upward and fills the gap with new igneous rock. Where an ocean plate is subducted. Well, let's think about that word right there. That's a pretty big word. But I was wondering if you could guess whether subducted meant going down under something or up over something. Sub. Where are subs? Okay, it means like when one continental plate is pushed under the other. When a plate is subducted beneath, there we go, context clues, a continental plate, magma forms and rises. The result is a volcano made of igneous rock. A collision of continental plates may push rocks so deep that they melt to form magma, leading to the formation of igneous rock. Sedimentary rock can also result from plate movement. For example, if the collision of continental plates can be strong enough to push up a mountain range, then weathering and erosion begin and the mountains are worn away. This process leads to the formation of sedimentary rock. Finally, a conclusion between continental plates can push rocks down deep beneath the surface. Here, heat and pressure could change the rocks to metamorphic rock. Conservation of material in the rock cycle. Constructive, construct something, build it, and destructive forces, destroy it, build up and destroy the Earth's land masses. But as the rock in the Earth's crust moves through the rock cycle, I want you to understand that this is going to be a recurring theme in some of the science that we're going to be learning this year. Material is not lost or gained. For example, a mountain can erode, but it forms this sediment, which eventually can form new rock. Now, material not being lost or gained, you might want to do the whole sentence there. This is called the law of conservation of material. Just like we have the law of conservation of energy, erase this, which we will get into. You never really lose energy. The energy of your food doesn't just go away. It's changed into the sounds that you make, the movements that you make. So kind of highlight this idea of the law of conservation. Okay, I'm going to stop there. I'd like you to finish the questions, and I think I'm going to look and see if I can find just a mini video just on this. It's hard to find one. It might be on all of the rocks, but it'll be short, and I'll attach it, and then tomorrow we'll go over those questions, and I will talk to you then. All right, have a great Tuesday. Goodbye.